Hello. Great. Next session, Nathan's going to be presenting to us. Let's get it started. Nice warm welcome for Nathan.
Thank you. Hey, my name is Nathan, and I'm a software developer here and engineering manager for the gaming team. I've never been afraid to tell others how I think software development should be done. And you know what? It's always just been my opinion. So I was intrigued when I found there was a comprehensive scientific study of which software development practices drive business outcomes. It's called the State of DevOps Report. Over a period of years, a team of scientists analyzed thousands of survey responses across tens of thousands of survey responses across thousands of organizations all over the world. Their approach is peer-reviewed, and it gives us the most defensible findings about software development that exist. And they've come to some pretty amazing conclusions. There is no trade-off between speed and quality. High-performing teams both move fast and they don't break things. There is also a correlation between team performance, as measured by technical factors, and financial success for the companies that employ them. But I think what's most significant is that their findings allow us to do something that before we thought was impossible, to compare the performance of software teams and judge the effectiveness of software practices in a rigorous and evidence-based way. Rigorous and evidence-based, that's kind of the key part here. Measuring and quantifying software development is not a new idea. Having evidence that those metrics drive good outcomes, that is new. So what are the metrics they found that predict success in software development? Before I tell you that, it helps to be more specific about what we're measuring. The study, the State of DevOps report, divides the work of making software into two parts. The first is product design and development. That's all the product work, the design, the UX, the implementation. It contains a lot of the fuzziness of what we do. It's hard to estimate, and it very often doesn't go to plan. The second part is product delivery. That's the build, the testing, and the deployment. There's a lot less uncertainty in that part, so that's what the study measures. But just because it's simpler doesn't mean it doesn't matter. There are huge, impactful improvements that can be made over there. And in fact, improvements in product delivery make improvements in product design possible. For example, it's much easier to have an experimental product approach if you go from shipping once every month to once every week. The performance metrics they identify are called the DORA metrics. They're named after DORA, the organization that publishes the reports. These metrics are a combination of speed and stability. The first, lead time for changes, is a classic lean metric, but in the context of product delivery, it means the time from a commit to that code getting into production. Shorter is better because it enables faster feedback on what we're building. The second speed metric is deployment frequency. More frequent is better again because it enables faster feedback and it makes each one of our deploys smaller and less risky. I'm calling these both speed metrics. Obviously, they're not things you improve by just typing quicker. What they're actually about is reducing the batch size of the work we do. So working in smaller steps. Moving on to stability. Time to restore service is the time it takes to deploy a fix when inevitably something goes wrong. Shorter is better. And finally, change failure rate measures how often a bad change goes into production. A lower rate is better. The studies provide evidence that these 4 metrics are linked to business success. That's a big deal. I'm not just showing you some lean metrics because I like lean. I've had good experiences in the past with lean metrics. I'm showing you metrics that are linked to success by peer-reviewed evidence. There may be other good metrics out there, but there are also irrelevant ones, and there are even harmful ones. What makes these special is they are the only ones we know lead to good outcomes. And it's not just business performance, incidentally. The evidence shows us that being good at these things leads to results like less deployment pain, lower burnout, and increased job satisfaction. There is no trade-off between speed and stability. This is a powerful conclusion. There are 2 plausible but opposite stories here. One is that going slow is safe, that the best way to do things is to gatekeep changes, carefully test them, and be very slow. That's how we protect quality. The other story is that going fast is safe, that the best way to limit risk is by keeping the size of our changes very, very small. Both stories make sense, but how do we decide which is right? The answer is we use these metrics and we use the science. As it happens, the second narrative is right. It's not necessary to compromise speed to get greater stability. In fact, teams with greater speed get greater stability. So, how are teams in the software industry doing according to these metrics? Here is a chart of software development performance from 2023, so last year's data. Teams clustered into 4 groups: high with elite group performers with 18% of respondents, high performers with 31%, medium 33%, low with 17%. Elite performers are writing and shipping code on demand, on the day. They have a low failure rate, and they recover from those failures quickly. Low performers are shipping maybe a couple of times a month. Their deploys are very chunky. They contain a lot of stuff. More often than not, something doesn't work, and then it takes them a long time to fix that. The medium team seems to be one that can deploy every couple of weeks. For example, a Scrum team who are shipping with their sprint demo every iteration would be a pretty normal team for the software industry. Elite and high performers, those guys aren't better or smarter than any of the other teams here. They're good at software, and they're better at enabling business outcomes. But that's mostly because they've chosen to do things like work in small batches. There was a thing that surprised me about this data, and that was who was in these categories. I had expected the high performance categories to be just full of web developers with shiny tech, but they're not. The type of technology a team uses is not predictive of their outcomes. So that means there are plenty of desktop and embedded developers in the high performance categories, and a shiny new web stack is no guarantee of performance. The evidence also shows that industry doesn't matter. It doesn't matter, for instance, whether an industry is highly regulated or not. Things like finance or healthcare are not special. These 4 metrics are still very good for them. So the next question is, what are the capabilities that drive software delivery performance? I said that we would be able to compare practices. So let's do that. What is the stuff that works? The answer is there are a lot of capabilities that drive performance. But since no one wants to be here all night, I've picked 3 that interest me: continuous delivery, architecture, and team experimentation. Continuous delivery is the ability to release all kinds of change on demand, quickly, safely, and sustainably at any time. Software is built in short cycles and always kept in a deployable state. This is an approach that prioritizes getting high-quality feedback quickly and often. That's the direction that the first 2 DORA metrics, the speed metrics, take us in, so it's no surprise that success in continuous delivery is a core capability that leads to success in software delivery. I believe that quick, high quality feedback leads to better software that is more likely to delight customers. But it's also the case that teams doing continuous delivery tend to get things right the first time. This chart shows the effect of continuous delivery on the amount of effort teams spent on rework in 2017. Teams doing continuous delivery spent about 49% of their time on new features and 21% on unplanned work and rework. Teams not doing CD spent 38% of their time on new features, 27% on rework. CD teams spent more time building new things and less time putting out fires. I hate that orange bar, and I love continuous delivery, because the orange bar doesn't just represent lost time. It represents disrupted timelines, angry customers, and stressed out developers. Continuous delivery requires continuous integration. Continuous integration is a combination of trunk-based development and a suite of fast automated tests. A team practicing continuous integration will integrate all of their work into trunk, or main, or master, at least daily. Each of those commits will build and test the software. The team will prioritize a breaking change over any other work. The only branching strategy here is do not branch, or at least avoid anything but very long-lived branches. Very short-lived branches. To hide functionality from users, we use abstractions or feature flags instead of branches. And because no one is branching, everyone is working on a very similar version of the code. That makes merge conflicts very easy, and it makes refactoring quite easy as well. The only trick is developers need to get good at splitting up big problems into small and correct changes. Branching strategies have always been a very contentious topic in software development. I've certainly argued about them a lot. But now we have evidence that an approach like this is the thing that gives us the most bang for the buck. And that kind of revelation is why I like this study so much. Onto architecture. Whether you're using Kubernetes or a mainframe, loose coupling of both teams and architecture is predictive of success. What do I mean by that? Teams with loosely coupled architecture can do these 4 things. Make significant changes to the design of their system without needing help or permission. Their code needs to be separate from other teams, and within their code, they need to be the ones calling the shots. Complete work without needing help. They should be able to deliver most features end to end without handoffs. So the way we divide our business domains into teams needs to somehow facilitate that. If a team relies on another team for manual deployment, manual testing, then that is problematic. Teams should be able to deploy their products or services independently of other products or services. And lastly, teams should do most of their testing on demand without needing an integrated test environment. What this tells us is that asking architects to set rules or design systems on behalf of teams isn't productive. Good architecture is about helping teams to find good boundaries, helping them to remove bottlenecks, and empowering them. The last capability I'm going to talk about is team experimentation. If developers on a team can only work on requirements or stories that are passed to them, and then despite their specialist knowledge, despite what they learn on the way, if they can't change those requirements or stories, then they aren't really working in an agile way. When we start developing, we know what business outcomes we want. On this little graph, we know which planet we want to land on. But the problem is the planet is moving. The scope or original plan needs to change. If we don't change the plan, we get the green line. We completely miss the planet. We don't achieve the outcome we wanted. But if we do try to change things just from outside the team, we get the yellow line. We get closer, but we still miss. We only get the purple outcome, the best one, by empowering them to change the plan themselves. But how do we know the purple line is better than the yellow line? I could have drawn anything here. We know because the evidence tells us that teams do best when they have the autonomy and the understanding to work on new ideas independently without having to get permission from outside the team, to write change specifications during development, and to make changes to stories and specifications without having to get permission from outside the team. So we've talked about continuous delivery, architecture, team experimentation. None of these capabilities are easy, and there are plenty more where those came from. But what we can say for sure is implementing these types of capabilities based on the DORA metrics I've shown you is worth it. The evidence shows us that it gives us better business outcomes, less rework, improved culture, less deployment, less burnout, higher job satisfaction. I think that's quite a remarkable thing to be able to say with confidence. Thank you. And I'll just say quickly before you ask about questions that if you want more resources on this, the first place I would suggest going is dora.dev. The screenshot there is a catalog of a ton of capabilities. I talked about only 3 capabilities. There are plenty more. Or reading the Accelerate book, which we have a few copies floating around. It goes into the evidence. If you're interested on how a sort of observational research project into software development is done, read that book. And we can also continue the conversation on the continuous delivery channel on Slack. Do we have any time for questions?